Hey everybody, this is Larry. This is me doing a bonus problem that I haven't done before. Let's get started. If you're new to this, it is April 5th, 2024. Every time I say that year. But basically, I try to do a problem that I haven't solved before with an RNG. And today we have a hard one. Also, and maybe a new problem with only 8 upvotes and 0 downvotes. So let's hope uh, let's hope things are kind and easy because I actually kind of want to take a nap, but it is what it is. The fate in a Ludus or anyway, 2921 maximum profitable triplets with increasing prices too. Is there a one? Should we do one first? And there's 6 hints. What needs 6 hints? Okay, fine. I was actually just looking at the constraints real quick. Actually, I was looking for a link for increasing prices one, but we're not gonna do that, I guess. Not today, anyway. So yeah, anyway, given zero index array prices and profit of length and there are n items in the store where item has a price of prices sub I and a profit of profit sub I. We have to pick 3 items of the following condition: prices sub I less than j less than k. Okay. If we pick index as ijk satisfying the above condition, the profit would be profit sub ijk. Return the maximum profit and -1 if it's not possible. Okay. So basically, you have prices. You have to find almost like increasing triplets, and then take the max of the corresponding profits. Huh. They're really for triplets. The way that I think about it, I mean, let me take a look at constraint. Constraints are 50,000, which is already not going to be n square friendly. Though it's a very weird way they write this, because usually they write it in scientific notation, but that's not really a big deal. And the profits don't really matter, and the prices don't. Well, I say the profits don't matter because I think it does. I don't know. And maybe I'm wrong, to be honest. But the texture of the problem just that it doesn't really matter. Because yeah, I don't know. Okay, prices may be interesting. 5,000 could be interesting because I don't know. I mean, 5,000 could be a dimension that we optimize on, so we'll have to think about it. But given that we have this relationship of price of I is less than price of j less than price of k, there are really a couple of ways to think about it. But the way that I think most and I don't know how to solve this yet, just to be clear. So we're all thinking together. So if I go the wrong direction, then you could just skip ahead or something. But you also get to see why I think the way I do, because I am articulate. I mean, usually when I solve hard problems, and these hard problems that I haven't seen before is during a contest. So this may be interesting, maybe not. You could watch it on 2x. And usually the thing that I like to say is if I go the wrong direction, that means that I'm learning something. So I'm excited for that. We'll see. And hopefully it's not an impossible problem, but it's like 6 hints, so I guess we'll get somewhere. But yeah, but the way that I like to look at these structures of 3 is that I like to pick the j, because then now we can bisect the prefix as left and the suffix as right, and they're all independent of each other, right? Or if you have prices of j, like let's say you iterate on prices of j, then i's and k's are actually independent in the sense that you can greedily, because for this thing, you want to maximize this and you want to maximize this. So almost feel like you get 2 problems into one if we're able to solve just this part. Because if we're able to solve this part, then we can actually solve the other part automatically. So in a sense that you could just invert things and go backwards or something like this, right? Like it feels very natural, unless I misread the problem or misread the problem, which happens as well. But yeah, for example, there's 2. If we look at this, we iterate on the j. There's nothing before this one, so we'll start on here. So j2, there's nothing smaller, and then so okay. So the idea here, I'm trying to feel right. Oh, so, okay. So we put in 2 because the idea here is that we want to get the subset of all the numbers that are smaller than, for example, we're at 3. We want to get all the. We don't have to maybe get all the numbers per se directly, but in some way, play around with all the numbers that are less than 3, and then get the max profit from those. Hmm. Now I'm just thinking, and I'm thinking in terms of this prices sub I is less than equal to 5,000. Because I feel like it allows us to do some prefix suffix things, right? I guess that's it, isn't it? It's a prefix some not prefix. It's a prefix tree thing, right? Yeah, the 5,000 is the big thing, isn't it? Huh? Because then now you could create what you might call it, the bit tree, the binary index tree. I mean, of course, you can also use seg tree and something like this, but I don't even think we need to. You could use the binary index tree, and then just kind of update these things, like, and you have a set property, right? Yeah, and then you get a minimum of all the prefixes from 1 to say 3, and you can also create another one for the other side, and then yeah. Okay, I think I got it. So just to kind of explain to people at home, sorry, because I'm just kind of working out a lot of ideas in my head, and usually I actually do write things down, but at least I haven't gotten to that point where I need it yet. But basically, because of prices, prices of I is equal to 5,000, you can think about creating. Let's say you don't know anything about binary index tree, and I'm not going to explain it that much on this thing. Let me type it out though, in case you want to Google it and learn more about it. The idea is that, okay, let's say you have, because prices of I is less than equal to 5,000, so you could create, like, say, an element of 5,000 elements, and you start with 0. Maybe 0 is fine. Yeah, right. And then here, let's say you process 10 and then process reset 100, right? So then now you go to the index 10 and you set to 100. I don't know if that's 10. It's roughly right? So just bear with me. And then here at 2, you set to 2, right? Okay. And then now for 3, we're at 3. So then we go, okay, well, look at the first 3 element. Oh, 2 is not 2. Oh, no, 2 is 2 for profit. So then here at 3, you go, okay, what is the prefix of 0, 1, 2? Maybe, I don't know that prices could be 0, but yeah, 0, 1, 2, say, doesn't matter, just the prefix up to less than 3, right? And then you get the maximum of it. So you, in this case, you actually, just to be clear, you have a max bit tree, binary index tree, and yeah, you could get that in log n time or log 5,000 times. So it's not even log n, because n is bigger than this, and that allows you to get the profit for the left side. And then we repeat for the right side, maybe, and that's really it. I think that's basically the idea. Okay, so now we have to that is awkward. I actually have template somewhere. The Fenwick. Oh yeah, it's also called a Fenwick tree. For some reason, I'm blanking out today. Let me. I actually usually use a. I'm not gonna lie. I don't really often template this, but But I'm a little bit lazy today, so I'm just gonna see where. These tags are so bad. Oh, there we go, maybe. Alright. I guess I didn't solve the other one. Why is that the... Oh, that isn't the... Wait. Oh, it's because this thing. Ah, okay. These are all... I've definitely solved this before, right? Like, problems with binary index trees. I'm just trying to find a... Okay. I'm just trying to find a... Oh, and I use seg tree on this one. Okay, fine. What is all this spacing? All right, this is my binary index tree. I have it in a website somewhere, but or at a, but I can't find it. So, or like, I'm not gonna look for it because apparently the site is down. But But yeah, but this is basically my binary index tree abstraction. I should probably should be able to do this, and this is a max one, so I don't even have to make any changes. But yeah, so okay, so how do I want to fix this? Right. All right, let's just get the left side first, right? So let's just get how do I set this up? Right, bit left. Let's just call it left, and we'll call it k right, right? Oh, man, I forgot how to write code. Let's just say mx, which is the max, is equal to max of prices plus 1 maybe. Yeah, and then that is the binary index tree, right? And then now we have we don't even need to care about the index, do we? Yeah. Yeah. So I'm not gonna go over how the binary index tree work. You just Google it. I'm sorry. I'm already kind of tired, as I said. And also, it's not an easy, at least for me. Like I don't have a quite good way of explaining it yet, to be frank. So maybe I need to work on that. My apologies. But I know that there are good videos on it because people keep on telling me about it on my Discord. So, yeah, I don't know. But yeah, so we have to keep track of the profit. So we have to, for price profit in SIP of prices profits, right? We have left dot update. You actually should update after you get the profits, but that's fine. But it doesn't matter because it should not interfere, right? Because you have to get, for example, for 3 you have to get 2 and less than 2 anyway, so it's fine. But yeah, so then we want to update price to be the profit, and here it already updates it to the max, so we should not yeah, we update everything to the max, so it should not matter. Like as in if 2 appears multiple times, and none of these examples do the same price appear, but by pigeonhole, some prices will dupe, right? Because of this, because there's 50,000 items and there's only 5,000 prices. But it doesn't matter. This will automatically get the max, right? Oops. And then now, but before that, we want to say, okay, so maybe we have say best left is equal to 0 times n, right? And then best left is equal to left dot get max of, so the price we want the price minus 1, and this will get us the entire prefix of from 0 to price minus 1, and that should be good, right? I just want to also print this out just for my sanity and testing these things real quickly, right? Just to make sure that, I mean, of course this is the wrong answer. What am I printing? Oh, I'm dumb. If this is I. Or yeah, index maybe. I was like, I don't know what happened to the rest of the array. But then I also don't update the rest of the array, so that was just silly. Okay, there we go. It's negative infinity because it doesn't exist, which is fine. Maybe it should be 0. Should it be 0 or... No, we want negative infinity so that we don't pick the first price by accident, for example, and take the 100% profit. So okay, so actually this is pretty good as a default, right? 2 and 7, so 4 is going to take the 7 as 3, which is good. So yeah, so I think for now it seems like it does what we want to do, and then now we have to just do the right side, right? Because we have the left side, the I side, now we have to do the K side, which is a little bit tricky, but the same idea, right? We want max profit. How do we want to do it? Because basically now we want the suffix, right? Because we want the max of whatever, but we can also just take the max minus the number to invert the ordering. So that should be what we do, even though I don't think I'm saying it that way. But for example, like we are seeing a 3, we want to see all the we want to see the max profit of all the numbers from 4 and greater, but we just invert everything by subtracting it from the max. Then now it becomes 2 or less than, which is basically the idea that we have before. So we can just do that. Basically like a invert operation. I have to be a little bit careful, because basically now we want to go backwards, because we want to process, so that when we when we process a number, we want to see the numbers to the right of it. So that means that we have to process from the right to left, so that you get the result in that way. It's very easy to mess up. It feels like. I don't want to write this loop. Maybe it's fine. Okay, so we have to reverse this array as well. So okay, so maybe something like this. I don't know if this works, because this may be an iterator, and then it just complains about iterator. Yeah, enumerate not subscribable. So we have to convert it to a list and then reverse it. Oh, maybe I could just reverse, right? That's actually a thing. Because I think reverse doesn't have to take a list. It could take a. Nope, I was wrong. But then we can just make it a list and then revert it. That's fine. But then now we have to be careful again, because now the index is of the reverse list, right? So here we can say index is equal to n minus index minus 1, I think. Right? So that we kind of get the right index on the original list. And then best of right of index is going to be right dot get max of. We have to also invert the price as we set, so that we can subvert the suffix and prefix thing, right? So that we could get numbers that are 3 and greater instead of 3 or fewer. And in that sense, then you get price is equal to mx minus price. This should be right, but I worry about off by ones and going out of bounds. But that, well, in that case, we'll just play around. Yeah. And profit we could keep the same. So yeah. Okay. Right. Let's take a look at this one. This one is easier to get well. It doesn't outright crash, which is good. So 3 looks at 4, 2 looks at 4 and is a 10, it's good. All these numbers, C is a bigger number in 5, which has 6 profit, which is good. And then the last one, or negative infinity, which is also good. Okay, cool. So then now we just have to put them together, right? So in range sub n, so where best is equal to -1, I suppose, because if nothing is found, it's -1. But yeah, and then it's just simply putting them together, right? Which is profit sub index plus best left of index plus best right of index, and that's it. Well, we have to return best. All right. Well, it was close. How did I get 17? Well, let's print it out. Why? Basically, yeah, debugging is important. Here we see that we have 17. The reason why 17 is interesting is because it is better than the expected answer, and usually that means that it's not well, it's definitely an implementation thing, right? Because let's say you have let's say you use a greedy solution or something like this, and you get another answer. Usually, greedy will give you a suboptimal answer, and what that means is that because the answer is suboptimal, it can only be under the expected answer, right? So that's like a minor debugging thing that you may pick up on. But yeah, let's actually print this out real quick. So okay, so 4 is 17. Am I off by 1 in some indexing? Maybe that's why. So index will go from 0, which is n minus 1. No, that should be right, but well, 4 cannot have the right answer. I guess maybe I do need this to be less than 1. As long as it's consistent. No, maybe that's too. Well, yeah, 4 cannot be the right answer just because when we iterate this is the J part, right? Because the best left is the I, best right is the K. So that means that by definition, it cannot be n-1 as the middle part, but which I should fix by doing something like this, to be honest, because that is more precise, right? But I also want to curious, like the reason why I am curious is because I did set up these railguards so that it returns like negative infinity, so that it doesn't affect the answer. So this is the reason why I'm curious why 17 comes up. It may be because of like some off by 1 indexing, and in that case, even if you fix it for this thing, there may be another bug that comes up in another thing, right? It's just that this kind of, you could hand wave over it and fix it, but that bug is still there and may come out in another input, and that would not be good. So this is why I am yeah. Okay, 4 is 656. Huh. Did I mess this up? Right does have a thing, but why? Index is okay, so index is 0 in the reverse list. Then index is going to be n-1, right? Price is, what is max of price? So oh, I need to do +1 because the way that binary index tree is a little bit awkward in that the way that I set up is that I didn't fix it, unfortunately, but the reason is, I just want to make sure, the reason is because no, we have a +1 here. It should be fine actually. So why do I that is awkward. Why is this best right 6? I mean, it is shown here. Do I do anything silly here? No, it's negative infinity. I mean, my gut instinct is that is still this part, right? But okay, so max is equal to max of price +1, so that's going to be 6. The current price is going to be 5, right? Yeah. So that means that price is converted to 1, and then this gets max of 0. I don't get it. Just want to double check. No, I didn't know how to read this. It should be before this, so it should be 0, 1. Did something weird come up? Why is it not reversed? Was it still? I mean, now we kind of get the idea why something is messed up. But as I said, that's why we have to dig into these bugs and stuff, just kind of fix it a little bit, hope it works. But isn't this reversed? Oh, I am dumb, because we did the enumerate and then we did the enumerate on the original one, so when we reverse it, we don't have to do this funky thing. Okay. Wow. But yeah, so that was really clearly a big one, right? Okay, there we go. So that was clearly an actual bug because I outsmarted myself, maybe if you want to call it that. But it was just because I'm used to doing it the other way, I guess. Or like I usually reverse it in the zip and then enumerate afterwards just by convention. But here, yeah, I think I was just being a little silly. And therefore, I did not need to reword it because it just does it. Okay. And then now, as you can see, everything is right in the row again, hopefully. Fingers crossed. Let's give it submit. And there we go. A little bit slow, to be honest, 2.4 seconds, but yeah, definitely, yeah, I mean, it's doable, and I don't think this is that slow. There's no intended solution, but I mean, yeah, let's go over the complexity real quick. We really only have three for loops, right? So it's pretty straightforward to analyze. This is a binary index tree update and a binary index tree get max. Each of these will take O of mx space and O of mx space and O of log mx time, where mx is the max of the price, which in this case is 5,000. Yeah, and so this is going to be O of n times log m. Maybe log m is straightforward. This is n log m, and this is just O of n, right? So yeah, so in total, this is going to be O of n log m time and O of n plus m space. Yeah. 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 I mean, I was trying to think whether I could get rid of this n of n space, and I don't think you could do it quite easily. At least not using binary index tree. I think actually, if you use a segment tree, you could maybe do it that way, but it's a little bit tricky to, because you have to be able to undo a max, which kind of gets a little bit weird. So you think of that case as like a sliding window, not even a sliding window really, but a scanline algorithm. But yeah. Anyway, that's all I have for this one. This has been interesting. Here's my binary index tree. Here's my other part of the code. And that's all I have for this one. Let me know what you think. Let me know how you did. Let me know if you're watching this. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.